Okay, so there are a couple elements of this. In the Module 5 guide, there's a table. And in this table, you see 6 pulsars. These are all kind of slow, about a second, maybe a few tenths of a second, maybe longer than a second. And bright enough to see. But they're not all easy to observe. The first one is pulsar 0329 plus 54. And someone in your group should observe that. Every group should observe 0329 plus 54. And then everyone in the group should pick another pulsar on this list. And these go from moderate to difficult to very difficult. Because the pulsars don't always pulse. Sometimes the pulses turn on and sometimes they turn off. So you may observe it and not get pulses, or you may get pulses. So the group should definitely hit 0329 plus 54. And then everyone in the group should pick one of their own other than that. Okay. I'm going to show you how to put in the 0329 plus 54, but it's the same directions for the others. So put in one of those for the team, then everyone on the team pick one of the more challenging ones. So I'm going to go to Skynet. You pull it over here. And we're going to go to radio observing. We're going to add a new observation. And you got to search for it with the PSR designation, PSR 0329 plus 54. Search for it, and that's just its name in the table. And it will find it, and it will put the modern day coordinates of it here. Min sun separation should be 10. We don't want to be too close to the sun. Min target elevation should be 20. We don't want to be too close to the horizon. Those are pretty standard defaults. Air mass chart, save and continue. Here's our receiver setting. And we're going to keep this in the default configuration. The low resolution mode, H1 filter, 80 megahertz bandpass. This is a nice clean part of the radio spectrum where you're not going to get a lot of radio frequency interference. Now, one thing that's very important, you see this thing that says pulsar mode? Do not, N-O-T, not click that. Some pulsars go very, very fast. And there are a few extra corrections you have to do. If you select pulsar mode, it will do the whole analysis for you. Just give you the results and you won't learn a damn thing. It's a black box. So in this course, we're limiting ourselves to slow pulsars where we don't have to worry about dispersion measure, these extra effects. And so we can do the analysis ourselves rather simply. So do not select pulsar mode, even though we're looking at a pulsar. Save and continue. I'll pick a time account. And then of the different path types, we're going to use the track. That's the simplest one. We're just going to follow it in the sky. Okay. And we're going to follow it for 3 minutes. That's 180 seconds. So duration should be 180. The integration time should be 0.021. This is as fast as it can integrate outside of pulsar mode. So since all of our pulsars are like a second or tenths of a second, this will give us many data points, or at least a handful of data points across the pulse. So we'll get a few data points where it's in the off state and a few data points where it's in the on state. So 0.021 is the rate at which we're going to get data for 180 seconds. Save and continue, and then submit. Okay, I have that in there. And, well, 2 more things. Everyone on the team should pick one of the other pulsars, do the exact same kind of submission, but then you need a calibration observation. There's a reason for that. Let's go back to our image here. These radio telescopes, you might remember, and I'll explain this more carefully later, they have two polarized detectors, one up, down, one left, right. That's the blue line here and the blue line here. As the radio waves come in, if they're polarized, let's say on this angle, you'll detect some in one channel and some in a different channel. So we're going to be comparing the intensities from the two channels, but the two channels are not calibrated with respect to each other. Just because you see more in one doesn't mean there is more in one. To really know that, we have to look at this in an unpolarized scenario. We need some kind of unpolarized pulsar to show that the other pulsars are polarized. Well, we don't have such things, so we're going to fake one. So 0329 plus 54, it's close to two bright sources that don't have strong polarizations. Cas A, right before it, and Taurus A, the Crab Nebula, right after. So we are going to fake a pulsar by looping on and off these largely unpolarized sources. Doing something called a daisy pattern. So here you see a 12-petal daisy pattern. We're just going to do a 4-petal daisy pattern for this one, but you get the idea. It's going to move in a loop on and off the source. So here we go. Going back to Skynet, radio observing, add a new observation. 0329 is between Cas A and the Crab, so you can pick either one. I guess I'll pick Cas A. Search on Cas A. There it is. It found it. You can also just click on it in the map. Again, 10 and 20, good numbers there. Save and continue. This one, we leave it alone, observe exactly the same. Save and continue. And here, we are going to do a daisy map. So we have to specify a couple things, the radius of the daisy, and that should be 135 arc minutes for this particular receiver and frequency. We're just going to do 4 petals. You have other options, but we only need 4 to calibrate one channel with respect to the other. And we're going to do these 4 loops in a total of 60 seconds. And you can leave that at 0.3. So it's going to create a data set that looks like a pulsar with just 4 pulses in it, but we'll be able to compare the throughput in one polarization channel with respect to another. And knowing that they should be the same for the source, we can use that to correct our other measurements. And we'll learn how to do that in a later video. So save and continue, submit. And if you're lucky, you can watch it do the daisy. I think it's doing one right now. Let's go to Green Bank Observatory, the Green Bank Telescope. Zero in, it's doing a daisy on the Crab. See the 1, 2, 3, 4 pulses? It's not really pulsing. There is a pulsar in the Crab Nebula, but that's not dominating the emission. This is something called the Pulsar Wind Nebula around the Crab that's giving most of the emission, and that's fairly constant and fairly unpolarized. Looks like it's starting up another one. So the little glitch here is it resetting the detector. Here's the calibration observation. And as it swings over, we get the signal. Here it comes around again. And we get the signal, and so forth. Okay, we'll end it there.